Just so everyone knows, I am attempting to create this video from the comfort of my living room, so I'm not in front of my smartboard, so the writing and everything might be a little shaky, and I might go a little bit slower. I hope not, but we'll try to make this smooth and hope you understand it well. Anyway, first, before we start this, I thought it'd be great to review. I know this stuff is very fresh, considering we've just learned it in the past month or two. But I did want to discuss it quickly, because since I know we all did not score the best or as well as that we wanted to on our linear equations quiz. So linear equations, it's essentially graphing lines. We put it in y equals mx plus b form and graph it from there. So here's an equation, 6x plus 2y equals -3. My instructions for you would be to graph it. So obviously the first thing we have to do is get it in slope-intercept form. So we're going to subtract the 6x from both sides there, which will give us this 2y equals -6x minus 3. Y is still not by itself, so we are going to have to divide both sides by 2. And that will give us this, y equals -3x minus 3 halves. Which once we have it in that form, we can easily graph it. Our y-intercept is -1.5, so I would go down to 1.5 on the y-axis, put my dot, and then my slope is -3, so I would go down -3 units and to the right 1. So my second point would be 1, -4.5. Or I guess you could have gone up 3 units, but we already did that. So if you need more review than that, by all means go back onto the Canvas website and go back and watch that 2.2 video. We're going to go back a little bit further to solving absolute value equations and inequalities. So here's an example of an absolute value equation. We had the absolute value of 4c equals 8. So to solve that, we have to remember the absolute value indicates distance. So this 4c is 18 units away from 0. So that could be 18 units to the right, which would be a positive direction, or 18 units to the left, which would be a negative direction. So we have to indicate the two values and set 4c equal to positive 18 and negative 18. And so to solve for c, then, we would divide both sides by 4, leaving us with c equals 4.5 and c equals -4.5. And then, of course, with absolute value, we have to check those. So 4 times 4.5 is 18, and 4 times -4.5 is -18, but the absolute value of -18 is positive 18, so that checks out. Here we have the absolute value of 2h is greater than or equal to 7. Remember, when we have greater than or equal to, it means or, because the distance is bigger than 7 units away. So it'd be or, typically shaded away. And again, because of absolute value, it can be 7 units away from 0 to the right or away from 0 to the left. So we have 2h is greater than or equal to 7. I should put or. 2h is less than or equal to -7. So we solve each of those inequalities by dividing, whoops, I knew this, that threw that one off, by dividing both sides by 2. And so doing that, notice when I wrote my second inequality, I flipped that inequality sign there. And then that would leave us with these inequalities of h is greater than or equal to 3.5, or h is less than or equal to -3.5. And again, we can check. 2 times 3.5 is 7. The absolute value of 7 is 7. -3.5, 2 times -3.5 is -7. Absolute value of -7 is positive 7. And 7 is greater than or equal to 7. And then, of course, we would shade that, or to graph that, we would have a number line. We would put a dot at positive 3.5, a dot at -3.5, and we would shade away. Because, one, that's what our inequality signs tell us, but also that's what an OR graph means to do. So, again, if you need further review, that video is still open on Canvas, so feel free to go back to Chapter 1 and find that video and watch it. All right, 2.7, what we're learning about today, two variable inequalities. So obviously you probably already have the hint that we are going to be talking about slope-intercept form, and so graphing lines, and we're also going to be talking about absolute value equations or inequalities and graphing them. I guess it's mostly inequalities, considering it's titled Two Variable Inequalities. So in this case, we have 4x plus 2y is less than or equal to 4. So to graph this inequality, again, we need it in y equals mx plus b form. So we'll subtract the 4x from both sides, leaving us with 2y is less than or equal to negative 4x plus 4. And then we have to divide out by the 2. And then that will leave us with y is less than or equal to negative 2x plus 2. All right, so to graph here, really nothing's changed. We go up 2, so I go up 2, I'm going to put my dot there, and then I use my slope, my m, and since that's a negative 2, I'm going to go down 2, I'm going to go to the right 1, or like I said, on the opening screen, you could go up 2 and to the left 1, and that still indicates a negative graph. And then what we typically would do is we would draw a straight line and go through that. And it would look like so. That's the best line I could get, which it's not perfect, but not horrible either. So to graph this inequality, same thing, we need to get y by itself. So this is essentially just 1/3 x, so the slope is 1/3, or at least right now it is until I get y. I guess it's not 1/3, I have to get y by itself first. So here we're going to subtract the 2, or at least that's what I did. I subtracted the 2, and then I divided by a negative 1. And remember, with inequalities, when you divide by a negative, you have to flip that sign. So positive 1/3 x divided by negative 1 gave me a negative 1/3 x. And then a negative 2 divided by negative 1 gave me a positive 2. And then I flipped that sign. So now I have negative 1/3 x plus 2 is greater than y, or y is less than negative 1/3 x plus 2. So same situation, we are going to graph that by plotting our y-intercept and using my slope to get my other. So my slope is again 2, which it looks like there's my y-intercept of 2. And then I'm going to go down 1 and to the right 3 here. Since that's a negative 1/3, I'm also going to go up 1 and to the left 3, since that's also negative 1/3. And now I'm going to draw a line to connect those points and to show that it's a line. All right, so there's my line. Actually, there's my line. Sorry, after I put it on there, I realized I did it wrong. So you might say, well, hold on, it's the exact same line. You're right, it is. The difference is this is a solid line, and it's a solid line because the inequality is less than or equal to. And this is a dashed line because it's just a less than symbol, not a less than or equal to. So that is one thing you're going to need to write down, is that it is solid when it's... Let me get it. Whoa. Like I said, it's a little shaky since I don't have my smartboard. Solid when it's less than and equal to or greater than and equal to. And it is dashed when it's less than or greater than. And that will never change. So make sure you write that down, something always to remember. Now, something else here that is highly important is these graphs are not done. Because it's an inequality, remember, this is saying everything less than this line is a solution to this inequality, essentially. So everything below this line should be a solution. Now, I know a lot of people get confused about knowing what's below or above, or not knowing which one's the solution. Pick a test point. The best one in my eyes is 0, 0. It's the easiest one to plug in. Plug that in to x and y here. So we'll have 0 here, which simplifies to 2, and then a 0 here. Is 0 less than or equal to 2? Yes, it is. So that means because that test point is true, a true statement, we shade everything below that line. And obviously this part should not be there, but I'm not going to go back and erase it. So everything below that line needs to be shaded. Here we have negative 1/3 x. Okay, so this line, and again, pick that test point of 0, 0. Pick whatever's point easy, plug it in. We have a 0 here, so we have 2. And then we have 0 here, which is 0. So we have 2 is greater than 0. Is that true? Yes, it is. So once again, we shade below that line. Now, if it wasn't true, you would actually shade away from that point. So this was true, so we shaded towards it. If it wasn't true, we would shade away from it, knowing that it's above the line. That's our solution, which hopefully on this next slide, you'll get sample problems of that. All right, so this is essentially the exact same stuff, except we do it with absolute values. So just like we graphed absolute value graphs, we have to graph these. Find our vertex. So in this case, it's going to be -2, -3, which looks to be at this point here. And then our slope is -1, because that's the value out front. So we plot here, and then its corresponding value, and that is going to continue, as you can tell here. So now it is greater than, so we are going to use a dotted line. So let me get that on. And then again, you're going to want to pick a test point. So again, we can choose 0, 0 because it's easy. Plug 0 in. We get 2, and the absolute value of 2 is 2. 2 times -1 is -2, and -2 minus 3 is -5. And 0 is greater than -5, yes. So in this case, we shade everywhere outside the absolute value or everything above it, whatever makes more sense to you there. So that would be my solution area in an absolute value inequality. And let's try, I'm going to stop before I mess it up even worse. Why don't you go ahead and pause the video and try this one. Remember to get y by itself first. So you'll definitely want to subtract the 3, but then remember with the 2, you can only divide it by the number outside the absolute value here, and then your constant term out here. You can't do it with anything inside the absolute value. So go ahead, pause the video, try that, and I'll put my solution up there for you. All right, so here, getting y by itself, I have this equation, which means my vertex is right 5, down 3.5, or down -1.5. 3 halves, I should say, not 3.5, down 3 halves. And then my slope is -1.5, so down 1, right 2. So that created this line. It is a solid line because it's less than or equal to. I chose my test point of 0, 0, and I was told that 0 is less than a negative number, and that is not true. So because that is not true, it doesn't make that inequality true, which means I shade away from the point 0, 0, which is everything inside or below the absolute value lines there. So let's move on here to now writing inequalities, not just graphing them. So as you can tell, we have an absolute value inequality, and we know that because it creates a V, and we have a linear inequality. So let's go ahead and write those. All right, so with this, I looked at my absolute value graph, and I said, all right, my vertex is here at -4, -3, which means in my absolute value, that's going to be a +4 and a -3. And it's open up, so it's going to be a positive absolute value.